Hello and Assalamualaikum. In this video, I will share the use of calculus in everyday life, which include two sectors, which is engineering and medicine. This project completed by two members, which is Mohamad Rosandi with metric number 286794 and Mohammad Shafiq Aqmal with metric number 286774. First of all, we need to know what is calculus. Calculus means small pebble in Latin, which is named by the rocks used by Romans for counting in ancient centuries. The founder of calculus is Sir Isaac Newton, which is one of greatest scientists and mathematicians in its history. Over centuries, many mathematicians have contributed to the further development of calculus as branch of mathematics and physics. What does calculus actually do? Calculus measures the rate of change that occurs in almost every phenomenon in universe. There are two branches of calculus, which is integrals and derivatives. Derivatives component of mathematical function define the rates of change at specific point, whereas integrals show the accumulation of discrete values of a function over a range. Without further ado, let's get into the use of calculus in medicine sector. The first one is surgical control of red blood cells. The blood in human body is made up of red blood cells. While undergoing surgery, a patient's blood volume has been maintained by injecting a saline solution that mixed quickly with the blood and dilutes as time passes. Calculus is used for computing the volume of red blood cells, so the proper amount of saline solution can be given to the patient during surgery. Second is pharmacology. Understanding drug sensitivity is crucial in finding the proper dosage for maximum output of drug integration. The side effects of a drug brought about by factors like body temperature change can be computed through integral calculus. Pharmacologists can make a kidney a changing function in the calculus-based Kropf-Kolk equation and determine the creatinine levels in the blood to access the kidney's functionality. Using this result, the dosage of drugs for treatment can be finalized. Next one is neurology. Neurology is the study of human nervous system, which is very complex networks of neurons that pass brain signals to the entire body and control all physical activities. The system consists of central nervous system, the brain, and the spinal cord. Integral calculus is used to compute the voltage of a neuron at a certain point. In contrast, differential calculus is used for calculating the change of voltage in a neuron with respect to time. Next one is epidemiology. Epidemiologists who conduct research on infectious diseases use calculus to discover the spread rate and area where an infection will likely occur. Calculus can also help create a containment plan and investigate the source of an infection. For example, like COVID-19 that has been spread around the world. Lastly, in medicine sector is entomology. Entomology is the study of insects. An entomologist conducts research, classifies insects based on species, and finds safe solutions to control insect infestation in indoors and outdoors environments. Calculus is used for modeling and generating insects proficiency through partial derivatives.
The use of calculus in engineering sector. One of the most important application of calculus in real life is structural engineering. Calculus is used to calculate heat loss in buildings, forces in complex structural configurations, and structural analysis of seismic design requirements. Architects use calculus to determine the increasingly important amount of material needed to build a resilient support system over time. Even notable monuments such as the Eiffel Tower are built using calculations to predict the effects of wind resistance. When designing bridges, civil engineers need to consider three structural elements, that is, beams, tension, and compression members. Using calculus, we can determine the amount of force acting on the beam, including the weight of pedestrians, weight of vehicles, and the amount of traffic anticipated on that bridge. Based on these factors, this material size and capacity can be computed. Integral and derivative calculations are important for calculating the voltage or current flowing through a capacitor. Integral calculations are also an important consideration when calculating the exact length of a power cable required to connect a substation several miles away. Mechanical engineering is also a good example. Pumps used to fill overhead tanks, garden equipment, cars, motorcycles, robots, and many appliances are designed using the principle of calculus. For spaceflight engineering, before launching a rocket or probe, engineers need to calculate the gravity of the sun and moon to know how to launch the probe and how to achieve the speed required to orbit the Earth. The conclusion is, learning calculus is not only beneficial to early scholars, but also incredibly useful to the child's future career. The examples provided will help students understand the importance of applying calculus to real life and why learning it is so important.